Good morning. Today we are going to start new lesson P block elements in second year chemistry. In P block elements there are 6 groups from 13 to 18. 13, 14, 15, 16, 17, 18. So 6 groups, but in first year PUC we have studied 13 and 14 group elements: boron, aluminum, gallium, indium, thallium, carbon, silicon, germanium, stannum and lead. This year, second year, we are mainly focusing on 15th group, 16th group, 17th group and 18th group elements. So first 15th group: nitrogen, phosphorus, arsenic, antimony and bismuth. So before to start this periodic table, the P block elements in the periodic table, you should have the knowledge to draw the P block elements. So the 3, 1, 2, that's a 2 L2 we have studied. So from 15 it is essential to draw, but practice to draw all the P block elements from 13 to 18. So just I gave a hint, just leave this, it comes at the last. Before this is the new elements. Before this there is another a shortcut method is there: boron, aluminum, gallium, indium and thallium. As you know, in the last year also I taught you. So here's an about you may learn from the other lecturers: boron, aluminum, gallium, indium, thallium. Bangan, alu, gajar, in thaili. So you can go for any other methods. Then carbon, silicon, germanium, stannum and lead. Kashi gaye Sant Prabhu. Kashi gaye Sant Prabhu. Then later you go for this. Same type you have to go for the 15th also. Just to learn this one, after 5, 6 elements can be joined here last. Nitrogen, phosphorus, arsenic, antimony, bismuth. Nepal, Pakistan, Australia, sab bikari hai. Then 16th, oxygen, just I repeat this one, 15th, Nepal, Pakistan, Australia, sab bikari hai. You may seek another views also. This is what method. That's just it is very easy to learn, that what we had learned, that only I am explaining you. You may seek another ideas also. Then your 16th group: oxygen, sulfur, selenium, tellurium and polonium. O se tipo. Here you should add mat. Mat in the sense not to do. Tipo means cheating. So not to cheat. O se not to teach, not to cheat. So here's an about the one method is just to remember, and another method also you can go for: fluorine, chlorine, bromine, iodine, astatine. फिर कल बाहर आई आंटी. फिर कल बाहर आई आंटी. You can learn the elements like this: helium, neon, argon, krypton, xenon, radon. हीना, नीना और करीना सब xerox रानी है. So this is the way short method. You may go different ways. So here is about how we learn. So this is P block elements. Just we have the, before to start this periodic table on the P block elements in the periodic table, then first we have, why do we use this P block elements? Just to have a glance. Which is our respiratory gas? Oxygen. See, oxygen is there. So oxygen is very important. So we have to know that oxygen is present in 16th group. Then we have to study this. Then another one about the king of chemicals. Which is the king of chemicals? Sulfuric acid. Hydrogen, sulfur, oxygen. See, H2SO4. H2 hydrogen is there and S is there. O is there. Sulfur and oxygen with hydrogen, it form H2SO4. So the king of chemicals is also come from the 16th group elements, it seems. So the next one, same type. We must aware of that one. The steamers, there is a one law is there. Steamers find the directions in oceans at night. Steamers find the directions during at night by using one law, Holmes' law. That is HOLME of ourselves, Holmes' law or Holmes signal. That is by using paspin and calcium carbide. Calcium carbide. So here's an paspin is formed by P, paspin hydrogen. So the Holmes law is also by made of this one. So that's the finding the directions for the steamers during night in oceans. So that is also one of the beautiful use from that the that what people. Then paspin is there, no, that has got wide variety of phosphorus reacts with hydrogen, it forms phosphine. The nitrogen we know very clear. So it is a very essential element for the plants. So plants need nitrogen. 73 to 75% of nitrogen present in atmosphere. So that is also essential for. If there is no nitrogen, the plants do not get into that action for the production of the food material. Then ammonia. Ammonia, that's about NH3. NH3 is also formed by this one. Nitric acid. Then proteins. Protein is nothing but nitrogen, oxygen, hydrogen, and carbon. So the nitrogen is also one of the very important thing in the proteins of the plants and animals. So nitrogen is also essential. Then we go for the bleaching powder, calcium oxychloride. So again, chlorine and oxygen. Calcium and chlorine have put together, that's in calcium oxychloride. Some of the chlorine elements are also used in the manufacture of the medicines. That's about what we can call that medical appliances. Then we go for ammonia. Ammonia is also formed by NH3. That nitrogen and hydrogen is mixed together, it forms nitric acid. That's an ammonia. Then nitric acid, HNO3. Nitric acid. See, when nitrogen is combined with oxygen, it forms different types of that. Those are also formed that one. See, different oxides, different hydrates. So these are combination of these compounds. And the balloons, in order to raise the balloons high. So how that one the chemical composition of the gases we learnt and mix it along with the hydrogen. One of the gas is mixed with along the hydrogen. That's an helium. So here it is. Hydrogen is mixed with helium, or helium is mixed with hydrogen. Then it forms in the balloons in order to that go high, that observe that balloons, how that the hydrogen balloons. So that is also by the thing. So this is a brief introduction. How do we use different chemicals? Many are there. Just I give that instances. So today we are going to learn that how the different elements are there. So first of all, I already told you in first year we learnt 13 group and 14 group elements. We have to stick on 15, 16, 17 and 18. Now we come to the 15th group elements. Just we focus only 15 group elements. As I told you, nitrogen, phosphorus, arsenic, antimony, bismuth. Nepal, Pakistan, Australia, सब बीमार है और बेकार है. Then this is the last element. We are not going to this one. Just to learn this one only up to nitrogen to bismuth. Then we come to the electronic configurations and atomic number of the 15th group elements. This is only 15th group elements. Nitrogen, phosphorus, arsenic, antimony, bismuth. This is nitrogen atomic number is 7. Then the electronic configuration you know. Then we have taken that noble gases. Helium, neon, argon, krypton, xenon. 7, 15, 33, 51 and observe this here. In the electronic configuration, when you write electronic configuration, the distribution of the electrons in the different orbitals, it ends with the p orbitals only. See, observe that one. P orbital is there. Here is also p orbitals. P orbital. So here's an inside of the p orbitals comes under the d. Just shifting this. So the p orbitals completely filled, and d orbitals also completely filled, and then p orbitals again p and d. So these whatever the elements you take, the p orbitals have to be filled. Then where is that Source of the elements, nitrogen. Already told you earlier in the introduction, 78% in atmosphere. And it's also present in different salts. The one of the salt is chili saltpeter, that is sodium nitrate. And one more saltpeter is there, potassium nitrate, that is Indian saltpeter. So this is about our nitrogen. Come to the phosphorus. Phosphorus in the form of apatite, fluoroapatite. Fluoroapatite. This is a combination of the calcium and, see, observe the calcium. Both are the calcium and the fluoride is there. Then phosphate. Calcium, calcium, and then phosphate. Then about the different three things are comes here: chloroapatite, fluoroapatite, hydroxyapatite. So different apatites are there. Chloroapatite, Ca3PO4 CaCl2. If Cl2 is replaced by hydroxide, that is hydroxyapatite. If the same type of that one, another is there, phosphates, calcium phosphate, that's for the phosphorus. So then another one, the elements, arsenic. Arsenic is in the very simple form. There is a real gar or real gar. There is As2 3, the red in color, which is red in color. Or one more is then orpiment, As2S3. This is yellow color. This is also the source which is present in the atmosphere. And stubnite, stannum stubnite, S2BO3, sp2s3. It's in the form of the fine dust, sp2o3. Then the bismuth is in the form of bismuth glands, Bi2S3. So this is the source. How do we get the different elements of previous? I think you are following very clearly. Then the second content is that now we are going to study about the physical and chemical properties, the trains in, just observe, trains in physical and chemical properties of P black elements. In this one we are taking the first 15th group. We are focusing on the 15th group. Observe the different periodic trains in the sense: atomic radius, ionization enthalpy, electronegativity. This is comes under the physical. Atomic and ionic radius. First you come to that. Then we go for chemical properties. How do the properties are vary in the P black elements? That is called trains in physical and chemical properties in 15 group elements. Observe here, just I draw the line here. Atomic and ionic radius. What is that line shows? This is groups. When you write that arrow mark down the group. If it is an above, that's an above the group. As we go down the group, nitrogen, phosphorus, arsenic, antimony, and bismuth, atomic and ionic radius increases. See, this is an about, just write this one. This is the increase. And again, here's a small arrow mark is there from nitrogen to phosphorus and arsenic to bismuth. From nitrogen to phosphorus, considerable increase. That's more increase. But from antimony to, arsenic to bismuth, small increase. So that will take. So why these atomic and ionic radii increases down the group? There is a reason is there that you should know. There is an examination point of view. Here it is done. Because the presence of completely filled d orbital or f orbitals are heavier members. Due to the completely filled orbitals, then they have the atomic and ionic radius increases down the group. If we are asked above the group means decreases. Then ionization enthalpy. Again, you have to go for that 15 group elements and turn armor decreases down the group. Because why the reason is, again you have to learn the reason. Gradual increase in size. As the gradual increase in size, ionization enthalpy decreases. Size and ionization enthalpy inversely proportional to each other. So come to this one. Here's an I is there. Delta IH means ionization potential, ionization enthalpy. That's about. Again, ionization enthalpy of that. Again, how that one, ionization enthalpy of 15th group elements are greater than ionization enthalpy of 14th group elements. So due to that, what is the reason is there? Extra stable off-filled p orbitals in electronic configuration. That's why ionization enthalpy increases above the group, decreases down the group. So that's about. And when you compare 15th group and 14th group ionization enthalpy, 15th group ionization and 15th group elements have more ionization enthalpy than 14th group elements. Then come to that electronegativity. Electronegativity, again, as we go further down the group, electronegativity decreases. Then just to combine all these properties in one shot, then you can come to this all the differences, because with increase in atomic size electronegativity decreases. Then we come to the chemical properties. When you come to the chemical properties, the elements which are going to react with the different elements, different chemicals. So first one, go for the covalent radius. As we learn that the chemical properties, we should learn the covalent characters of P black, sir, 15th in P black elements 15th group. As we learn the covalent characters, covalent character decreases down the group. As that one, nitrogen has more covalent character than phosphorus, arsenic, antimony, and bismuth. So this is about the another one. Then come to that, the reactivity towards hydrogen. When these P block, the 15th group elements are reacted with hydrogen, with NH3 it forms H3 it forms ammonia, phosphine, arsenic hydrates, antimony hydrate, and bismuth hydrate. What about the things are comes under? Here's an MH3. M is the element in the 15th group element molecule, then hydrogen. Then thermal stability. As the thermal stability is there. So here's about the thermal stability. Just to observe the thermal stability, how it goes on that the thermal stability decreases as we go down the group. Thermal stability decreases down the group. That I have not written. Please note it. Thermal stability decreases down the group because of the molecule and with hydrogen MH bonding. MH bond strength decreases. Decreases down the group. Remember, thermal stability decreases. So this is another character. In that one, covalent character, reactivity. So nitrogen is a less reactive or more reactive. So if you come to that one, as it decreases down the group. So decreases down the group in the sense, let's go for that reactivity. With ammonia, that's with hydrogen, it has got more thermal conductivity. Hydrogen has more thermal conductivity. Then we come to the next one, reducing character. What is the reducing character of the P black elements? In that P black elements, 15 group elements. So again, we are focusing the 15 group elements. Increases, reducing character increases. Observe that one here and one share is there. Nitrogen and hydrogen, ammonia, phosphine, arsenic hydrates, antimony hydrate, bismuth hydrate. Here's an ammonia is a good reducing agent. This is because most stable. And here it is bismuth hydrate. It is unstable, strong reducing agent. One more questions will be focused on. Strong reducing agent. Which is strong reducing agent among these hydrates of the 15th group elements? Bismuth. Bismuth hydrate is strong reducing agent. And ammonia is a good reducing agent. Then we come to this one. Melting point and boiling point of 15th group elements increases down the group due to increase in size. Go for ammonia and phosphine, and it go for increases. So therefore, that's about the melting point and boiling. Both the characters are comes at the same point. And come to that another one, reactivity towards oxygen. What happens if the 15th group elements reacts with oxygen? It forms formation of oxides. 15th group elements forms oxides. It may forms trioxides or pentoxides. 15th group elements M is, and 15th group elements trioxide and pentoxide. Come to the another one, higher oxidation state. What happens higher oxidation state? Higher oxidation state is due to more acidic nature. That's what more acidic nature come from the higher oxidation state. And lower oxidation state, it forms less acidic in nature. Depending upon these one higher oxidation state and lower oxidation state, more acidic property and less acidic property. So as we go in that the 15th group elements, acidic character decreases down the group. So here we can go for all oxides of nitrogen and phosphorus are strong, strongly acidic. Strongly acidic. Decreases means it's first is an early strong. Except two, nitrous oxide and nitric oxide. Nitrous oxide and nitric oxide. This is laughing gas. Again we learn in the next one, it is called laughing gas. This is nitric oxide or nitrogen monoxide. But oxides of arsenic are weakly acidic in nature. And we go down, antimony. Oxides of antimony is an amphoteric. It shows both the acid and basic properties, which is that one, antimony. Then oxides of bismuth is weakly basic. So strongly acidic, weakly basic. So how that one it go for? This is and the middle one is amphoteric. This is about the acidic characters of 15 group elements. Now we are going to learn in a group some of the elements are going the different types of the properties. That's called anomalous behavior of or anomalous properties of nitrogen. Anomalous properties of nitrogen. You could see clearly. So just focusing. Anomalous properties of nitrogen. So nitrogen shows some anomalous properties due to its own reasons. What's the reason? This is a main points for the reason of the anomalous behavior of nitrogen. So nitrogen has got small size and higher electronegativity and high ionization enthalpy and non-availability of d orbitals. So these are the four reasons repeating for all the anomalous properties of nitrogen. Shall we go for that? How that anomalous properties takes place in nitrogen? For example, the first one is formation of p-pi multiple bonds with carbon and oxygen. Nitrogen forms p-pi multiple bonds. Why? Because due to large atomic orbitals cannot overlap effectively. So due to large atomic orbitals cannot overlap effectively. So that's about the reason for p-pi orbital. It only forms p-pi orbitals, but not the other elements. Other than the nitrogen, other elements, only that nitrogen can form p-pi. But other elements, they do not form p-pi multiple orbitals. Then come to another one. Higher bond enthalpy. So how that one higher bond enthalpy takes place? Here's about higher bond enthalpy in nitrogen is 941.4 kilojoules moles inverse. Because due to the triple bond between the two nitrogen atoms. But other elements it only forms the single bond. Antimony, phosphorus, arsenic, and bismuth, same time. Then low reactivity, it is also having low reactivity. Because of the bonding, all the electrons are get used up. It shows low reactivity. So it is used, nitrogen is also used to create inert atmosphere. So that will come under the uses. And we study in the later classes. Now, inability to form d-pi orbital, which one? Nitrogen. It cannot form d-pi. It's only form p-pi orbitals. Because absence of d orbital. See, the same thing will come. Smaller size, high electronegativity, high ionization enthalpy, and in a incomplete field d orbitals. This will come under the anomalous properties of nitrogen. Now I come to the today's last content. Dinitrogen. We are going to prepare dinitrogen. We have to learn something about dinitrogen. Dinitrogen, 2 molecules of nitrogen. It is present in atmosphere in air. Then 80% of weight by air. How do we prepare this dinitrogen? Here is one reaction is there. By taking that ammonium chloride and sodium nitrate. By mixing these two compounds, ammonium chloride and sodium nitrate, we obtain ammonium nitrate and sodium chloride. This is unstable. Again, that unstable ammonium nitrate is heated. It forms nitrogen and water. So we got our compound. What is our compound? Dinitrogen. So these are the reaction. When ammonium chloride and sodium nitrate is mixed together, it forms ammonium nitrate, and then ammonium nitrate is unstable. Again, it is heated. It forms nitrogen and water. So this is one method, lab method. and it forms impurities like NO and HNO3. While we are doing this one, we are getting the impurities nitric oxide and HNO3, nitric acid. This is nitric oxide, sorry, nitric oxide. This is nitric acid. This is acid HNO3 as impurities. But these can be removed by passing through the aqueous sulfuric acid, by passing through the aqueous sulfuric acid. That's about the purification process. And second one is, how do we prepare dinitrogen? By thermal decomposition method. Another method of preparation of nitrogen is by thermal decomposition of ammonium dichromate, NH4 twice Cr2O7, ammonium dichromate. Keep this term in your own mind. You are getting one more compound in lab, potassium dichromate. So then another one is ammonium dichromate is heated, it forms chromite, nitrogen and water. Here we got our required dinitrogen. Then the last one is that commercial method. Commercial method, how do we prepare dinitrogen by commercial method? As we told, the nitrogen is present in the atmosphere. So, and oxygen is also present in the atmosphere. So by fractional evaporization, nitrogen distills over at the boiling point of 77.3 Kelvin, and oxygen distills for 90.04 degree Kelvin. So we know that fractional distillation in petroleum extraction, same type here and also here we go for this one. So this is the reason how that one, the fractional distillation and the fractional evaporation is going to be conducted, the commercial method of extraction of dinitrogen. So my dear student, thank you. This is the first copy of the P block elements. So we have learned the different copies, and I start in the next one. Thank you one and all.